Hello class, this is section 8.3 on geometric sequences. So a geometric sequence is when you have a common ratio. That means you're multiplying a constant to get the next term. So in this case, it looks like you're multiplying times 2 to get 10, and then if you multiply times 2 again, you get 20, and if you multiply times 2 again, you get 40. That means that there is a common ratio, which is 2. Therefore, it is a geometric sequence. So just to recap, so if you multiply 5 times 2, you get 10. 10 times 2 is 20. 20 times 2 is 40. Because it's common each time this number is fixed, that means it is a geometric sequence. And so that is our answer for that. All right, let's see. The first 4 terms are given. Let's see if this is a geometric sequence or not. So to get from 1/5 to 1/6, you would have to multiply by, well, the way you can find common ratios in general is to do the second term divided by the first term. So in this case, it would be 1/6 divided by 1/5, which is 1/6 times 5 over 1, which is 5/6. So if there is a common ratio, it would have to be 5/6. But let's test it with the second and the third term. So in this case, to confirm, you would have to do the third term divided by the second term. So the third term would be 1/7. The second term is 1/6. If you multiply by the reciprocal, you will not get the same thing. You're going to get 7/6, which is not the same thing. Not the same. Therefore, there is no common ratio. So this would definitely be a no to the geometric sequence. And we're supposed to enter D and E if it does not have one. All right. Determine the common ratio, the fifth term, and the nth term of the geometric sequence. This time they're telling us that it is a geometric sequence. Therefore, we can apply that formula to figure out what the common ratio is. It's the second term divided by the first term, which in this case would be -11 over 121, which would simplify to 1 over -11. So that is our common ratio. Notice that you could also have found it with the third divided by the second. You'd get the same thing. Or the fourth divided by the third, which is also the same thing. In order to get the fifth term, well, we can just multiply by the common ratio. So the fourth term times the common ratio will be the fifth term. So in other words, the fifth term is going to be the fourth term times the common ratio. Fourth term is -1 over 11. And the common ratio is also -1 over 11. So that's going to be +1 over 121. All right, and then the nth term, well, there is a formula for geometric sequences. Nth terms for geometric sequences are as follows. A sub n equals a sub 1 times r to the n minus 1 exponent. So this is the formula for a geometric sequence. Notice it's different from the arithmetic sequence. So we know what the first term is. It's 121. And we know what the common ratio is. It is -1 over 11. And therefore, we should be able to find this. A sub n is equal to the first term times the common ratio raised to the n minus 1 power. So that will do it. That is our final answer. The sum, all right, for sums of finite sequences or series, there's a formula for that. So let me bring that formula up for you. It would be, here it is. It is S sub n, this is for geometric sequences, is a sub 1 times 1 minus r to the nth power over 1 minus r. So this is the formula for partial sums of geometric series. All right, so the problem is we don't know if it's a geometric series because it doesn't say. So we have to test it to see if it is. So let's see, to get from 1 to 3, the common ratio would be 3. And then let's see, if you multiply 3 times 3, you get 9. So it does appear to have a common ratio. Therefore, we can assume that it is a geometric series. So in order to figure out n, we need n. We need to know how many total terms there are. So therefore, we're going to have to go back to this formula in order to figure out what n is. So we know the last term, we know the first term, and we know the common ratio. So that'll allow us to solve for n. So let's do that now. So the last term is 6, 5, 6, 1. The first term is 1, which I won't even write. Common ratio is 3 to the n minus 1 power. So let's see if we can rewrite this number in base 3 form. So let's experiment with some numbers. I'm going to experiment with 3 to the 10th power. That's too high. 3 to the 7th power. That's too low. 3 to the 8th power. And that's right on. So 65, 61 is the same as 3 to the 8th power. All right, and now because the bases are the same, we can set the exponents equal to each other. That's a one-to-one property for exponential functions. So that implies that n minus 1 must equal to 8. Add 1 to sides, n equals 9. So now we know that there's 9 terms all together. And now we can substitute all the values into this formula to get the sum, this partial sum. All right, so S sub 9, since there's 9 terms, is equal to the first term times 1 minus 3 to the 9th power minus 1 minus 3. So that's going to be the same thing as 1 minus 3 to the 9th is 19683 all over negative 2. So this is going to be negative 19682 over negative 2. And if you divide that, you're going to end up with the final answer, which is 9841. 9841. So there were 2 formulas that we needed. We needed the general term for a geometric series in order to find out what n was. Once we figured out what n was, then we went up and we used the sum, the formula for the sum of the first n terms of a geometric sequence. And we got this as our final answer. Okay, moving on. So notice that this is another series, and this time this one is infinite because it's got the ... at the end, which means it continues indefinitely. So we need to determine whether this infinite geometric series is convergent or divergent. The way you can tell is you have to figure out what r is, and then you take the absolute value of r. If it's less than 1, that means it's convergent. And if it's greater than or equal to 1, that means it's divergent. If it's convergent, then we're allowed to find the sum. And the formula is a little bit more simple. It's this formula right here. It is the first term divided by 1 minus r. So it's a little bit more simple than the previous formula. So first thing we should do is figure out what the common ratio is. Well, to get from 1 to 1/3, that means we're multiplying by 1/3. 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1 over 27. So our common ratio is 1/3. And if you take the absolute value of that, you'll notice that that's less than 1. Therefore, it is convergent, which means we can use the formula to find the sum. If it would have been divergent, you would have said that the series is divergent. But since it's convergent, that means we actually have to find the actual sum. So let's plug in the values. The first term is 1. R is 1/3. And we can change that to be 3/3 minus 1/3, which is 1 over 2/3, which is 3 over 2. So that is our final answer. The sum, this infinite sum, is 3/2, 1.5. Moving down to this last problem, it says a truck radiator holds 5 gallons and it is filled with water. A gallon of water is removed. So a gallon of water is removed from the radiator and replaced with a gallon of antifreeze. Then a gallon of the mixture is removed from the radiator and again replaced by a gallon of antifreeze. This process is repeated indefinitely. How much water remains in the tank after this process is repeated 3 times? So think of this as a sequence. It's a geometric sequence. We're starting with water, 5 gallons, and then the next time around we replace 1 gallon with 1 gallon of antifreeze. So now we only have 4 gallons of water. And then the next time, well, notice that we can figure out what the geometric ratio is. The common ratio is 4/5 because that's how you find common ratios. Second term divided by first term, which is 4/5. So each time we're going to have 4/5 the amount of water that we had in the previous time. So this next one's going to be 4/5. I'm sorry. You're going to, you're going to multiply 4/5 times 4, which is 16/5. Then you're going to keep doing that. You're going to multiply this by the common ratio, which is what? 16 times 4 is 64. 5 times 5 is 25, and so on and so on. We can keep doing this. Multiply the top one by 4, because that's a common ratio. So 64 times 4 is 256 over 25 times 5 is 125. And so this process repeats indefinitely. ... So let's see. How much water remains in the tank after this process is repeated 3 times? So here's the tricky part. If you think of this as a first, second, third, fourth, fifth term in the geometric sequence, when they say repeated 3 times, they're not counting the first time, because the first time there's no repetition. So this is really like the first repetition, second repetition, third repetition. So after 3 times, this is the number thereafter, 64 over 25. That's how much water is in the tank. All right, how much water remains in the tank after this process is repeated 5 times? So remember, this one doesn't count, so it'd be 1, 2, 3, 4. So we need to do this one more time. So you multiply this term by the common ratio. So 256 times 4 is 1024. And then 125 times 5 is 625. So this would be the 5th repetition. This would be the 4th repetition, the 3rd repetition. This is the 2nd repetition. And this is the 1st repetition. And this is the starting point. So our answer for this one would be 1024 over 625. How much water remains in the tank after this process is repeated n times? So n time is the general term. So that would be first term times the ratio n minus 1 exponent. So we know the first term is 5. The common ratio is 4/5 to the n minus 1 power. So that is our final answer. So that's going to be 5 times 4/5 to the n minus 1. And that concludes this section.